The final bit I want to talk about is the control plane for running this kind of service. And I couldn't give a talk here without mentioning that we're also starting to use TiDB for the Databricks control plane, and it's a very exciting technology for that. So the Databricks control plane is all our infrastructure that runs the customer workloads, keeps them going even when cloud machines fail, when there are storage problems, when various things go wrong. So that itself is thousands of nodes across more than 100 regions, because we operate in the three major clouds here, Amazon, Azure, and Google. And they each have many regions, and we need to deploy our services in each of them. So we have many instances of this control plane that together manage these millions of worker VMs. And it's really important for it to be highly available and scalable, because people are building production applications. As you saw, 1/6 of the jobs are actually streaming jobs. So we can't go down when running these applications. So how did we start out building this? When we started out, we just built stateless Kubernetes services, and we used MySQL as the main database, and we used the version provided by each cloud, because we thought, hey, this is just a control plane. It's not going to need super high volumes of data, right? How many customers could we have? How many jobs could they have, right? It can't be that many. So that's what we started with. But over time, we saw that actually all these things are going. Customers come in, they set up a production job, they set up 100 production jobs, they set up 1,000, they start running automated queries that each submit a job, so you get a lot of them. Same thing with users. You go from a few expert data engineering users to maybe everyone in the company wants to connect and create notebooks, power dashboards, and so on. So we're actually starting to hit the limits of MySQL scalability in some of the largest cloud regions, and we have individual customers who want to run even more stuff. And we also ran into problems with the availability of it, especially for these real-time applications. It's not easy to maintain even single-node MySQL, to deal with all the software updates, to fix it when things go wrong, and to do all that while avoiding downtime. So we started to look at TiDB for our next generation control plane, and we chose it as kind of the system to go on. And there were a bunch of attractive properties we liked. Obviously, coming from MySQL, we really liked the compatibility because we could migrate to it. But another subtle aspect that maybe people don't think about is when you're rolling out something like this, you always want to be able to hold back. So we wanted a technology where, if something's going wrong, we can switch back to our old MySQL system. And it's really important to have the compatibility work both ways. So writing one query and being able to swap back and forth is really nice. Horizontal scaling, of course, very important. Zero downtime. You can upgrade the system, all without bringing anything down. And also, HTAP was really interesting to us because as people run these workloads, they want to analyze what they're doing on Databricks in real time. So, which jobs are running, when are they failing? If you're running many of these, it's really important to do that in real time. And without this, we would need to take many minutes at least to deliver that data to them, and to write a lot of complicated logic for that.